Hello. In this talk, I'd like to discuss the weather and climate of Texas, including climate variability and climate change, and how that relates to stream flow, rivers, estuaries, and basically overall the aquatic resources of Texas. To start with Texas climate, we need Texas geography. Texas is located first off on the eastern side of the Continental Divide. The mountains to our west provide a barrier to both air and water that might be carried from the Pacific Ocean. So that gives us mostly a continental climate. We don't have the ocean influence of the Pacific. We do get some effect from the Atlantic Ocean, which is our source of moisture. About 90% of the rainfall that falls in Texas comes from Atlantic Ocean water. And the flow from the southeast that we get during the summertime brings the summertime thunderstorms and occasional tropical disturbances. The mountain barriers also channel cold air that's coming down from the north. That gives us our continental influence in wintertime. And so this time of year, as we're now experiencing, you can get very large swings in weather, depending upon whether the air is coming from the north or coming from the south. We also end up with several seasons of rainfall. In the wintertime, the jet stream is far enough south that we get disturbances in the jet stream, cold fronts, precipitation associated with frontal systems. In the spring, it's storms that form along the dry line, which is the boundary between the moist air coming from the Gulf and the dry air coming from the higher Mexican plateau. In the summertime, we get southwest monsoon rainfalls in West Texas, and again, occasional tropical disturbances coming both from the Atlantic and from the Pacific Ocean. Rainfall across the state increases very dramatically from west to east, as you're undoubtedly familiar with. Less than 10 inches of rainfall near El Paso compared to over 60 inches of rainfall near Beaumont, Texas. And that variation is due mainly to the fact that the Gulf of Mexico is south of East Texas, but it's harder to get moisture up into West Texas. Also, the altitude plays a bit of a role there as well. Consequence of that is that really West Texas is dry compared to East Texas. Precipitation is part of the story. If you look at the hydrologic cycle, precipitation controls the inputs to the cycle, how much water is going to be arriving on the soil to soak in or to run off. But the other factor is evaporation from water or evapotranspiration from the land surface. And the rate at which that happens is controlled by mainly sunlight and temperature. So changes in our water resources, particularly drought occurrences, depend both on the amount of rainfall and the temperature. So the difference between precipitation and evapotranspiration basically says how much water is typically going to be available to run off. And here's a map of the United States showing that difference. And you can see in West Texas, it's one of the driest parts of the country. There's less than 25 millimeters of rainfall on average available for runoff. That's less than an inch. Whereas in East Texas, we're near with the darker colors, where we've got several hundred millimeters of rainfall that typically run off during a typical year. So Texas, although it is a single state, actually represents a spectrum of climate conditions. And it's really hard to characterize it as just a single system. And that's particularly true because the streams tend to originate in West Texas and flow toward East Texas. So a single river basin, such as the Colorado or Brazos or Trinity River, will include both arid parts of Texas as well as the wetter parts. And unfortunately for water supplies, the heaviest rainfall tends to occur near the end of the rivers, near the coast, rather than upstream. This is different from, say, most of the western United States, where the heaviest rainfall occurs at the origin of rivers, which then flow toward the drier portions. Texas water supplies fight both climate and geography. And also, it's not just the average that matters. The variations about average matter as well, especially for West Texas, because typically the ground is dry and normal rainfall may be enough to soak into the ground and make it wet, but you really need excessive rainfall to get significant runoff. We can see the difference in the hydrologic systems when we look at the history of reservoir levels in different parts of the state. Here's Sam Rayburn Reservoir, which is in East Texas, and you can pretty well see the annual cycles. It's quite rare that you go through a winter without actually filling up the lake, and it gets depleted during the summertime. You can find a few droughts in here. The current drought was intense in 2011, but the lake pretty much filled up again in 2012, and it filled up again in 2014. By contrast, Possum Kingdom, let's fix that. Possum Kingdom Reservoir has been dry or below capacity for several years now. It's only received significant inflow once during this drought. That was in early 2012. And so now we're down to levels which are near historical, which have only been seen back in the drought of the 1950s. But again, reasonably normal rainfall ought to be enough to fill up the lake. But now you consider, say, J.B. Thomas Reservoir, which is in West Texas. Last time it was full was back in the early 1960s. It only once every 5 or 10 years receives significant inflow. So you can see in the current drought it's been effectively dry or nearly so. Although if you look real close, you can find a dramatic uptick right at the end. It's actually now at 40% of capacity because of a flood event, about 12 inches of rainfall in one county earlier this fall, and that was enough to halfway fill up the reservoir. So, unlike in East Texas, where you've got reliable rainfall and reasonably steady stream flow, streams are flowing constantly, West Texas flow is intermittent and much more erratic and flood prone. So this current drought is now the second longest drought on record for the state of Texas, going back to 1895. We're looking at the intensity of it here using the Palmer Drought Severity Index, and that black line shows the current drought. The only drought that's been worse than it is the drought of the 1950s, which is the orange-yellow line that extends all the way out to the right-hand side of the graph. The current drought is different from that one, mainly because the 1950s drought had its driest year at the end in 1956, whereas this drought had its driest year at the beginning. So we had very intense, severe agricultural impacts the first year, and ever since then it's been mainly a story of water supplies and lack thereof in certain places. Now, Texas is a drought-prone state as well as flood-prone. The rainfall is very erratic, and that's true even on a multi-decade time scale. On the bottom, I'm looking at precipitation average from January or December through March for each of the 10 climate divisions in the state. I'm plotting as percentage of normal, so 100% would equal normal, and each of the horizontal lines represents a 20% change. So we're seeing swings of 40 to 50% on a decade basis in wintertime precipitation. And furthermore, that's, well, partly caused by and strongly affected by what's happening in the Pacific Ocean. Something called the Pacific Decadal Oscillation, or PDO, is like a long-term version of El Nino and La Nina. They tend to run in streaks. And right now we're in a period of time where PDO is negative, which means the large-scale pattern in the Pacific resembles a La Nina, which tends to be dry in the wintertime for Texas. You can see all the curves are basically dipping downward as this 4-year drought that we're experiencing starts affecting the 10-year averages. There's not nearly as much variation in April through July. It's also not very strongly related to sea surface temperatures. But then we get into August through November, and now our influence mainly comes from the Atlantic Ocean, which also has a multi-decade mode of variability called the Atlantic multi-decadal oscillation. And here the correlation is negative. When the Atlantic is warm, we tend to be dry in the summer and fall. The drought of the 1950s, again, shows up on this graph. The different regions are moving around in different ways because rainfall in the late summer and fall can be quite intense and localized because it's coming from tropical disturbances. And you can see we're heading back down right now to go along with the warm ocean temperatures. Really, both the Pacific and Atlantic Ocean for the past 15 years or so have been tilting the climate odds toward dry conditions in Texas. And that's why we've had several droughts during that period, including the current one. In the summertime, temperature and rainfall are pretty closely related. Here on this graph, each dot represents a different summer in Texas. I'm plotting average rainfall from left to right against average temperature from bottom to top. And you can see the wetter it is, the cooler, or let's say less unbearably hot, the summers in Texas tend to be. Now the big red dot in the upper left is the year 2011, which was the driest summer on record and also the hottest summer on record. It's not surprising that both of those happened at the same time. If you're going to be record dry, you're probably going to be record hot as well. So we've got natural variability taking us between a dry, warm summer and a cool, wet summer. But if you look at the years that I've labeled here, maybe some of you can see those, most of the years in the 2000s are above that diagonal line, which means that independent of the rainfall variations, there's something else going on that's making our temperatures warmer, and that's long-term climate change. Temperatures have gone up about a degree or two over the past 40 years in Texas. So that's taking this whole envelope upward on this diagram. And it means that future droughts won't necessarily be more frequent, but you don't know for sure how precipitation is going to change in the future. It might increase, it might decrease. But one thing that is pretty certain is that temperatures are going to go up, and that means that droughts are going to be warmer than they used to be. And evaporation is going to have a more important effect on drought intensity than it used to. So the climate model projections for precipitation show that Texas is sort of in between the where rainfall increases and where it decreases. If we zoom in on Texas, you can see that we're close to the zero line. Not much change in rainfall, especially considering how much variability there is from decade to decade. That variability is going to dominate our rainfall for the foreseeable future. Also, runoff is expected to not change a whole lot. Even though evaporation should make the ground drier, climate change also increases the amount of water that can be present in the atmosphere at any given time, and so it increases the maximum intensity of rainfall. So we should get more intense rainfall events, which will help keep runoff overall about the same as it has been. However, soil moisture is projected to dry out. You can see that the southwestern United States is one of the so-called hot spots where soil moisture really declines a lot, despite the fact that, as we saw, rainfall isn't projected to change very much. And so this will have an impact on water demands and also an impact on stream flow and flow into bays and estuaries. The stream flow will become more episodic if the soil moisture dries out like this. So to summarize, the climate in Texas is quite variable. You don't get the same thing year after year, and that's because it's influenced strongly by the Pacific and Atlantic Ocean. And stream flow is even more variable because even with normal rainfall, especially in West Texas, you may not get much stream flow except for those really intense flood events. Climate change is expected to increase the amount of flooding, although the base flows will probably decrease because the soil moisture is going to projected to dry out, water tables become lower, and that in turn will have an impact on stream temperatures and water resources. And it's hard to predict what's going to happen with natural variability, except to say that it goes in these cycles, and right now we're in the middle of a dry cycle. Possibly in 20 or 30 years we'll have very few droughts because the Pacific and Atlantic Ocean may be in a favorable configuration. But then inevitably we'll be in another dry cycle again sometime down the road later in the century, and at that time temperatures will be even warmer than they are now and potential impacts will be greater. So that's what I prepared for you. Although I can't really answer questions right now, you can contact me by phone or by email, and I've also included the website for the Texas State Climate Office. So thanks for your attention.